activity, so it's your responsibility to check the canvas. I guess it's you supposed to get the notification, right?
Yeah.
Any due date or the event, so you need to check your email or the message box. So it's a good idea to check the 1 or 2 times the beginning of a week, what is the due date and any other activities. Okay. So today we are going to continue the relational model. Okay. So to summarize briefly what we have done so far, we have information. Okay. So from the information, our goal is to build a database system. So that is our goal. Where the computer, it can be server, it can be the computer, whatever. Anyway, so for that system, we like to use something DBMS system, which represent database management system. It's a software such as Oracle, Informix, DB2, IBS, MySQL, SQL Server. Probably there are 100,000 such a DBMS. For example, we are going to use the Oracle database. Oracle even has the 6, 7, 8, 9, 2, the 12. The C nowadays, C stands for the cloud, but you don't have to worry about the number. So anyway, so this is our goal from here to here. However, information itself do not fit to such a database system because as I mentioned many times, this is a computer. Computer can understand only structured data. Okay, structured information, which means it has a data structure. So if you are learning if you are training for the program language, it's a program language as a software to communicate with the computer. You can ask, you can order something task using your program. At the time, you need the data structure. Okay, actually, data structure is everything that you learn, that you cover in computer science system. But different way of the data structure. Sometimes it can be viewed as the algorithm. Sometimes it's a directly data structure. Okay, like the integer or it's a data type. So all of these are data structure. So this is our goal. So for this data structure, we are going to use relational model. What is a model? Model is a kind of concept or constraint. Okay, that limit, that organize, format, make the format. But it's much bigger than just a simple algorithm. Okay, in the simple algorithm, it has something logic, but this relational model for what? It's to manage very large data. Okay, so that is our topic right now. But before that, we start from the information. We need to little bit organize it because it's not organized, the information. So we use the ER modeling. It's a conceptual level modeling or high level modeling. From information, we little bit organize, like using the ER diagram. So we have such a thing. And each one has the absolute, something like that. As you can see, it's much better than this one. It's easy to understand. That's our goal. At the time, we identify entity and also relationship and so on. It was not very difficult, but it needs your a little bit effort to practice. Okay. Then, however, this is not the database object. This doesn't fit to the computer system. Okay. You can develop something, the program or algorithm that software can identify and detect. From the ER model to this one, pretty much that's the one with opportunity. Anyway, let's do over. So we have a little bit gap between this high level data modeling and this is called the database modeling. Database modeling too close to the computer. This one is close to the human perception. It's a high level. We cannot say this is a low level. It can be a physical level, but it's a conceptual. It's a little bit hard to say that this is a physical level. Physical level is one side. In terms of the 3D schema architecture, this is like this one. Okay? Conceptual level. So not the external level. Internal level is the physical level. But this is just organizing the information, so we need to reduce the gap from high-level design, conceptual level design, and the database design, database model. So today we are going to finish the definition of the what is the relational database model. We have discussed a little bit about the relational model. What is a relation? So a relation is a group of the data. That is a key point. So when we regard the data, it's not record by record, which is popular, which is general in other computer science modeling. Okay, think about your object-oriented model. Think about the C programming. Think about any other data structure. Usually we consider data. Let's say this record by record. Sometimes if we have the sequence of data, then we can consider array of the data. That doesn't mean it's a group of the data. Array is just a sequence of the data. You can copy, copy, copy. Then you have the series of them. However, relation and model itself consider data as a group itself. Okay, that is actually the innovative idea that differentiates from the other. The data model. So using such a idea, group of the data, so we can define the relation as group of data, group of row, sometimes group of attribute, or group of column. So that is the definition of the relational model. Today we will see what is the characteristic of such a relational database model. Then after we finish this relational model, then we will learn how to convert this ER model to relational database model. Then pretty much that's done. So we start from the information, then ER model, conceptual model, then relational model. The remainder will be how to, that is a model, but somebody already implement software based on that model, that is the DBMS. We will see how to access, how to create the data, how to access the data, how to manipulate the data. That will be discussed in the next week. Then pretty much it's done for the database design. So fast. So, what is the relational model? What is a relation? The last class, so we have talked about such a definition and even the informal and formal ways of the relational model. This slide shows the summary of such an informal and formal definition of the relation. So our goal is to find a number of relations. Okay, so that is the same as the table. Most of the students probably heard about the name of tables. It's just table. It's exactly the same as what you have known and what you have understood about the table itself. Yes, that's a table, and table consists of a number of columns by number of rows. Similarly, we have the number of attributes, number of tuples, but actually originally the relation has been defined based on the domain. However, because it's not easy to implement the domain itself. Why? Domain is kind of big. There are all possible customer name. How many customer names are possible? It's almost an infinite number. So can you keep such all possible customer name? No, it's not easy. So practically, we are not going to use the concept of domain in the database management system. Instead, we are using data type, like the string, or number, or the float number, or the integer. So that data type is a little bit general concept. Okay, instead of the domain, if we are using character 105, kind of is a maximum size of the string. Okay, character. So, however, that's practically easier way than the domain. Okay, and we have the tuple that represent the number of rows and the domain. So our goal is to find the table definition, which means schema of the relation. So that is called the relational database schema. That is our goal. So if we can find such a relational database schema, then that's it. Based on that model, we can create the table using what? At that time, we are going to use the SQL. It's a database language. Anyway, database management system is the application running on computer. So their language is different from the human being. So we cannot use the C language, we cannot use the Java, we cannot use the human natural language. We need to use their own language, that is the structured query language that follow relational model. So we will see next week about this one. So this one shows the example of the student relation, student table. That doesn't matter. So interchangeably, I'm going to use throughout the semester student table or student relation. And group of tuples, it has the total 5 tuples. Also, it can be viewed as the number of column, number of attributes. It has 1, 2, 3, 4, 5, 6, 7 attributes. Okay. As we have discussed last time, sometimes some of the data are missing. Okay. That doesn't make sense because the tuple, each tuple should have the same format. So to address that problem, we can use the null. So we will see later on the null, about the null, a little bit more. Okay? So the null means no, existing. Okay? However, as somebody mentioned, anyway, it keeps the computer research. The more null you have, the less performance. Okay, it's not good for your performance of your system. So ideally, null-free database is the best one, which is not possible. It's the ideal case. Okay? So we can use some notation. The capital letter represent the usually not. This is not the general notation. Depending on the project manager, when you are assigned to the real project, sometimes your project manager use the different notation, but in general, so generally the capital letter represents the relation name or table name, and the small letter, the lowercase letter, represent each data tuple or row. Okay. However, in SQL, database management system, database structured query language, database management system, DBMS, are not case sensitive. Okay? It doesn't matter whether you create a table with a lowercase or the uppercase, it doesn't matter, but usually we prefer to use capital letter for table name and for the data, lowercase. Also, sometimes we can use the dot to represent table name attribute of the table name. For example, the student dot the name means it's a name attribute of student table 1. Sometimes you may have the same employee table also has the name of employee. Okay, to differentiate this name and this name is different. They may have different domain. They are from student name domain. They are from employee name domain. Their data type may be different in practically. For example, this can be defined as a data type kept string, 10 bytes. This one may be 20 bytes. So even though they are sharing the same name, however, they are different. So to represent, to differentiate, you can use the relation name or table name dot the attribute, column name. This approach, this notation will be used for where DBMS in SQL. Okay. So from now on, we are going to see what is the characteristic of the relational model. So it can be summarized. So what is a modeling? What is a data model? What is a database model? When we are saying the such a modeling, what is a model? It can be viewed as, it can be defined as group of constraint. Okay? It makes sense. So for example, the student. So you should not do this. You should not do this. You should not do this. You cannot drink. Right? So you can give the constraint. Then you can imagine what is the student. Student should not drink. Really? Anyway, so that in terms of the such a definition of the model regarding to the constraint. So we are going to identify the three main constraints, three main concepts, three main the characteristics. So that is one is the key constraint, another one is the entity integrity constraint, and third one is referential integrity constraint. Some of them you already heard about, knowing. Okay, let's start from the key constraint. You can imagine what is a key constraint. Key means it's a key attribute, or sometimes it's a composite attribute, composite key attribute. Using key attribute, you can identify actually entity in terms of ER modeling, right? Similarly, in the relational database model, we are going to identify from the example of the student, we can identify specific tuple or row. For example, social security number. Using the social security number, we can identify the specific data, specific row. Right? This is called key attribute. Okay? So, however, key attribute, let's start from this one. What about the social security number plus phone number? Can you identify each student using social security number, comma, phone number?
Yes.
Yes, because you can use the social security number, then add the home phone number, doesn't matter. What about address here?
Yes.
Yes, definitely. So actually there are many ways, many combinations to identify the specific data. Okay? At that time, this kind of key number of how many? Social security number plus the home phone number, plus address, plus the office number. You can make as many as possible. It might be limited, okay, finite number, but you can make the many number of such a combination of the attribute to identify the data that is called super key. Okay? So first you can identify the super key. The reason why I mentioned starting from the super key is, in this case, it's obvious. Everybody can imagine social security number is unique, so it can be key. However, in general, sometimes it's not easy to identify such a key attribute. So we are going to start from general case that is a super key. So how many super key? Many. Okay, we can identify as many super key as possible. Then, actually, we don't need this one, right? We don't need this one. Only social security number. So minimal super key. So minimal means if we take out the attribute, that's an effect to identify the specific data, student, right? However, if we take out the social security number, we cannot identify, right? This social security number is called minimal super key. Okay? So from the super key set of the super key, we can identify minimal super key that is called key attribute, also is called candidate. They are candidate. Okay? They are not key yet. Okay? So candidate key. So we can start from the super key. As long as you can identify the specified data, that can be super key. How many super key? And many combinations. Among them, you can find minimal super key, like the social security number. Here, even we can use the name to identify sometimes how many minimal key, minimal super key. Social security number and name. We can find 2 or more the candidate key. Okay? So that minimal super key is called the key or candidate key. Okay? Among, for example, in this case, we have the social security number as a candidate key and the name as a candidate key. Finally, we will decide one of them as the primary key. Only one. So how many minimal super key? It can be 1, 2, 1 more. But however, how many primary key? Only one. The other super key will be candidate key. I know. Second, I think that I got wrong. It's not candidate key. So minimal super key or key, then we select one of them as the primary key and the other will be candidate. Okay? So candidate key means it's in the minimal super key. It's a key attribute. However, it's not selected as the primary key. So the key constraint means in relational model. First, the key constraint. Each table, the relation should have only one primary key. Is it possible the table without primary key?
Yes.
No, that doesn't allow. That's the different from ER modeling. ER modeling allow the entity without key, right? Such as weak entity. However, relational model does not allow the table without primary key. So each table, each relation should have at least one key attribute. Among them, only one primary key. The other will be considered as secondary key. Secondary key and primary key, what's the difference? No difference, actually the same. Right? Same means it's not the social security number, no. Their role is the same, but only one will be selected to represent this relation. Then somebody may be curious, how we can select the primary key among many the keys? How?
Unique.
Depends on
Both of them are unique. Depends on
the database that you have.
database. You don't have database yet. You are designing database.
Data type.
Time, performance, yes, maybe you need to consider the performance.
Duplicate.
None of them duplicate. Because when we identify the key, it starts from the super key. Definition of the super key is unique. That's your job. You need to decide based on requirement and application analysis. So, which means there is no general way to decide which one is better. However, sometimes obvious, for example, in this kind of example, for example, what if we have UBID, another one, right? Definitely you will use this one as the primary key. Because most of the application will be based on UBID. When you log on the web advisor, you will use the UBID. When you access the email box, you will use the UBID to identify yourself, so UBID, right? However, if this is the employee, especially for the payroll office, which one are you going to use? Assistant. Why? Many of the payroll most of them are related to social security numbers due to the tax problem or the other credit issue. So social security number will be selected. So that is the idea. So which means, so sometimes I try to use this one as the primary key. If you have the reasonable, if you have the reason, okay, if you have the rationale to select this one, yes, it's okay. So it depends on your requirement, it depends on the application analysis, it depends on the types of query, okay, that you are going to design in your database system. So no general way, but it depends. Okay? So that is a primary key. How many candidates? Sometimes you can have 0, sometimes 1, sometimes many. They are the same as the primary key, but it's not selected. Later you can use this one for index later. Why? Because it's also unique. It's a good way still.
So fast access.
It's not better than this one, but still it's one of the way to find the data. Okay? So we will see later about that. This is the key constraint. Somebody may be curious, those especially who had a little bit experience working with the DBMS system. Like for example, in your programming class, you already use the SQL Server, right? As a database source. Did you create the primary key? Sometimes not, sometimes yes. Even though you do not create the primary key, no problem, right? Why? That means the Professor Lee is wrong. In general, implementation of the database system, this is too strong, okay, constraint. Some of the people would like to create the table without primary key. Primary key means it doesn't allow duplicate data. Actually, it's a pros and cons together. When you have the primary key, it's very easy, okay, to identify the student, because I have the terrible pronunciation. So if I call your name, nobody can understand. But if I call your ID, everybody can understand. It's the best way to identify the student. However, if you do not have the UBID, you cannot be here. Right? It's a very strong constraint. Same thing in the database system. So some of the people complain, I'm developing the database, so I'd like to test, but because of the primary key constraint, I cannot create the table. So database management system, most of commercial systems allow creating table without primary key. That doesn't mean you can create the real practical database, product database without primary key. That causes serious problem. Why? For example, student, there might be without UBID, social security number, you need to create. Sometimes there might be nowadays a lot of Matthew, right? And Nicholas. So my son, Nicholas. So usually he has 1 or 2 friends in this classroom, same name. So Nicholas. Probably last name is different, but same name. So hard to identify the student. It will cause a serious problem later. Okay. So that is the first constraint. First constraint is what? The primary key constraint. The table relation should have must run primary. Okay? So that is different from ER model. The next one is it unique or not?
No.
No. It's unique, but
Unique, you don't know where it is.
Unique?
No. I mean, it's in the set.
No.
Anyway, it's a unique. What about this one? Another nine. Is it unique or not?
unique.
How many of them unique? Only one. How many of them is not unique? Does it make sense to compare the 3 with
No.
null? Doesn't make sense because null means not exist. So you cannot compare yourself with the ghost, right? That's terrible. Right? Doesn't make sense. Which means when we compare, we cannot compare this. Just ignore it. Which means this is the unique. More sophisticated. So we are going to use this number as the key. Lee and CS. 1, 2, 4, and 2. James, Emmy, and none. Tom, E. We have the 3 tuples in a relation. Is it unique or not? Based on this.
No.
It's a unique.
Oh, right.
Because we cannot compare this, so we ignore this. Still unique. However, we cannot identify never ever this Tom using student UBI. Right? In terms of key constraint, it's okay because it has a unique primary key ID. Because null does not consider. Because of that, second constraint is entity constraint, integrity constraint. That is, primary key should not be null. Okay? So that is the reason you probably heard about definition of a primary key before. What is a primary key? If you search the Google or the Wikipedia or whatever, any textbook, primary key is unique plus none. That is the reason. So second constraint is entity integrity constraint. That means should not be null for primary key. Now you understand why primary key is unique plus not null. What about candidate key?
Unique, that's not.
That's only require only uniqueness. It doesn't matter. So when you select the primary key, you need to consider null or non-null case also. So null, it cannot be comparable. You cannot compare. Can you count? Or not? Even you cannot count. How does it make sense to count how many people in this room?
No.
So probably 40 students plus a lot of ghosts. Do I need to count? I cannot count how many ghosts are in this room probably. I'm not sure. There might be ghosts who die. Too much study, right? So that ghost want to stay here. Can I count? No. Null does not exist, so you cannot count. That caused a later serious problem. Like for example, you have for example, GPA 3, 4, 3 on average. What is the usual average? Summation of the number divided by n. At that time, if you divide by 1, 2, 3, 4, 5, however, it will consider only 3, something like that. So at that time, when you divide by this, you need to use something not null data. It's really happening. Even nowadays, everybody realized such a problem. So very, very cautious. But a long time ago, when first time the relational database has been used for banking system, even balance GPA is wrong. It's slightly different because they are not cautious for the divisor. Sometimes they consider null the column. So that is the key constraint and integrity, entity integrity constraint. It's a very strong constraint. Because of that, relational database management system very fast to search the data. Unique, non-null, so we can easily, if we can apply the indexing or ranking, it's very fast. However, because of that, not easy to maintain the constraint of the data. Somebody may have, some student may not have the UBID. I want to just sit on the here the audit the class, which is not allowed because there's no. So it's a very strict rule, which means not flexible. Okay, relational database model. It's not always the best solution. If your application, if your system needs some flexibility, you need to think about
So
the others.
it's pretty much similar to hashing.
Hashing is a little bit different. So we will see the hash later, okay? Not hash chocolate, so we will see the hash. That's good. The hash is a very important data structure
Right.
in database also. So we will see hash here later, especially in the file structure used in the database system, probably after midterm exam. Okay? And the last one, referential integrity, is one of the main characteristics of the relational model. That's different from the other. That is, so let me give the very quick example of that. For example, we have the student, employee. We have the employee, and we have the department. Employee has the social security number as the primary key. Okay, it has some name, ID, not ID, it's a student, name, address, and department number. If you go back and remind the handout, chapter 7 handout, we have used the
Department.
company database. Why don't you keep in mind that the ER diagram, okay? So then it has some information and also department number, okay? Department number that where this employee is working for, okay? Then also we have the department information, D number, which is unique, is clearly mentioned, so we can use as the primary job there. Then other information over here. So I'd like to populate. I'd like to insert the data into this system. For example, employee, like the 111 Lee, address is 100 the University Avenue. DNO, I don't know, whatever, 100. Okay, and another 112 and the James and the 99 University Avenue, I don't know, 200. Then later, when I populate the department, D number is clearly mentioned in the requirement 1, and department name is the HR, something like that, and supervisor. And 2 is the payroll. So do you think it's okay? Actually not, because of this. This employee should work within this department, one of this department. So to address that, you need to check the D number of the department for the annual of the employee. Then you can see this one, so 1. The James works for payroll office, something like that. Then which means this D annual depends on the number of the department always. It's another constraint, another condition, another rule of relational database model. Very important rule. Because of this one, actually, we can manage the purity of the database. Okay? We do not have the noise data because of this. One, we do not allow any other employee who are not working for this. Only within this department. At that time, this kind of the constraint is called referential integrity. So this column, this attribute is called referencing attribute. Referencing column, and this one is called referenced color. Okay? Referencing and reference color. This is called foreign key. You heard about the foreign keys. If you are not, it's time to understand what is a foreign key. Foreign key means it's a constraint to refer this one. Why don't you go back to the programming assignment where you use the database? Did you create the foreign key? Not many students actually create the foreign key for classroom project. Does it cause any problem? Not much. You did your project. That means we don't need referential integrity? No. How? Why? That you didn't use and why? You don't have to use at the time. Because it's the same problem as a primary key. Many of the users, actually, if you have such a rule, this DNO, department where employee is worked for, this department should exist in DPT, department table or relation. However, sometimes there are new employees who are not assigned anything. That may be possible. So you wanna ignore such a foreign key or referential integrity. Many users complain. So practical implementation of the DBMS, they allow without foreign key or without referential integrity. Then what can be the problem if you do not create the foreign key or referential integrity? Somebody will insert data without department, right? So there might be a lot of input. And also sometimes you can delete whatever the department, even though there exists the employee. Does it make sense? So, but I'm working for the HR department, but somebody delete HR department, so nowhere I can work. So we cannot verify, we cannot guarantee such a database constraint without such a foreign key relationship. However, sometimes you can manage such a constraint without foreign key. How? In your application program or in your interface. You can give only the option to enter the new employee 1 or 2 in your application program. But it's very risky. What if there is a new department? There is a new department. You need to change your application program and compile it every time. It's a tedious job. And if you are lazy, you may not update. So that is a reason in terms of the relational model, when we have such a relationship, okay, we will create referential integrity. Okay. So there are 3 constraints. One is a key constraint, which means unique. Second, the primary key should be non-null. Okay, unique plus non-null. That is a key into either entity integrity constraint. The last one, referential integrity. This is a problem. So one time, it is true to hire the experienced database administrator. We talk about a little bit. What is a database administrator? It's a system administrator focusing on managing the database management system, database itself. The sum of the big company, they separate the job, like the operator, database administrator, DBA, and database architect, database designer, something like that. Sometimes database administrator, DBA, conduct all the job. Sometimes there is no database administrator. Most of the small and medium-sized company with who manage developer. Sometimes even the manager managed such a database system. They don't care what's going on. Whenever developer changes the database, the architecture, it's okay. So when I consulted one of the company system is a medium-sized company, I surprised. I was shocked when I log on the system. First, their table name is like T1, T2, T3. Really, with the column name C1, C2, C3. Then next, no primary key and no foreign key. So it's just classroom-like the program. When they open the system, no problem. But a year later, it's a disaster. They cannot manage. Sometimes two same customers are in the table because of the no primary key. And also, sometimes the employee works for the totally the different department because it's not controlled constraint. Okay, so that is the reason. So when you, however, it's true to manage such a constraint, especially the referential integrity. It's very tough, not easy. For example, one of the examples is I'd like to create the employee and department and insert. Okay, at that time, if you create the employee, okay, then if you want to create the foreign key, no, you cannot create. First, you need to create the employee and department first, then create this. So you need to think about the order of creation. Also, another thing is I'd like to insert 1 million of employee. Okay, then which means millions of time you need to check constraint foreign key. Takes a long time. When you have the 100,000, it's okay. You cannot realize the difference. However, when you have the million, 10 millions of the data, 1 day and 2 days are huge difference. Right? So sometimes intentionally you do not manage the referential integrity. Instead, you can manage such a constraint within the application layer. Okay, in your program. That's true. But it's not recommended. Okay? So that is the constraint. Yes?
So the referencing and the referenced attribute should have the same domain.
Yes, correct. That's a good question. So, what about the DNO and D number? They are from the same domain. In terms of the concept of a domain, it's easy to understand, right? If they are from the same domain, so we can do that. What about the data type? Data type should be same? Not always. It can be number 10 digit. It can be number 11 digit, even as long as the contents are the same, 1 to 3, then will be accepted. Okay? But actually, when Dr. Yef proposed such a modeling, his idea is based on the domain. But nowadays, it's as long as type comparable, okay, and data is the same, then it will be accepted. Okay? So, for example, sometimes it can be the character 3. It can be number 3. But you can some of the DBMS convert character 3 to the number.
Yes.
Then it's as long as it's the same value, it will be okay.
So, because when I was creating some tables in the SQL Server, I have to make the two the data type the
Yes.
same and in the same domain, of
Yes.
course. And the foreign key can be null.
Foreign key,
Yeah, sometimes can be null, but the primary key cannot.
yes. So as long as the type comparable, so it's okay. But value should be the same. Or not the same, or should exist. One or is referenced. Also intentionally you can disable the constraint. That is also possible. So 3 constraints, that is the main characteristic of the relational model. Key, unique. Entity integrity is not null, and the referential integrity is for the foreign key constraint. Okay. So we are going to use the underline for the primary. Okay, just like the key attribute in ER. But key in ER is different from primary key in the relational model. It's a different modeling, but they are quite similar. Actually, that was the reason we select ER model for conceptual model and relational database model for our database model. So entity integrity model or entity integrity model is not null. The primary key should not be null. And referential integrity is referencing to referenced. And referencing can be null or not. It can be null. If you are not sure of this one, you can give the null. Because null cannot be compared, so it is okay. In addition to 3,